So welcome everyone. Welcome to Strait Science. Strait Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus here in Nome and University of Alaska Fairbanks Alaska Sea Grant. And tonight you're in the home office and both Northwest Campus and Alaska Sea Grant, we are public servants of the Bering Strait region. We serve all peoples of the Bering Strait region, which is the homeland and waters of the Inupiaq, St. Lawrence Island Yupik, and Central Yupik peoples. So tonight, no stranger to Strait Science, Jessica Crance is here in the house, and she is back. If she's not talking about one species of whale, she's talking about all species of whales. So before she's been on for right whales, and she's also given us updates on tonight's talk. And tonight we're going to hear kind of the update of where we are on this for the Bering Sea region, both southern and northern. So Jessica Crance is a research biologist, I would say a whale biologist for sure, with the Marine Mammal Lab at the NOAA Fisheries Science Center, which is in Seattle. So not only is she talking to us after the workday, but she's talking to us an hour later than for us. So Jessica, I hope they give you don't have to come in till lunch tomorrow, but hopefully it'll work like that. But anyway, we're very excited and we're very glad you're here. And we're very excited to hear about what you have found, what your group has found doing these surveys, because as we know, like it says in the flyer, how some of these, oh no, not that's, I'm getting confused here, but how some of the data you're collecting will be used for your population estimates and abundance and things like that. So that's very exciting to all of us who are keen on the whales and our marine ecosystem here in the Bering Strait region. With that, we're so glad you're here. Take it away.
Great. Thank you so much. Yeah, it's always a pleasure to come here and speak to the Strait Science series. So tonight I'm going to be talking about kind of 4 years of marine mammal surveys that have been happening in the Bering Strait and more recently the Southern Chukchi. I did give a presentation last year with some of the results that you'll see here. So for those who saw last year's talk, there will be a little bit of repetition, but hopefully there's enough new information in here to make it worthwhile for you. So I briefly want to share some background on the Pacific Ocean Whale and Ecosystem Research Program, or POWER surveys. These are visual line transect marine mammal surveys that have been systematically surveying portions of the North Pacific and Bering Sea to obtain information on abundance, density, and stock structure of large whales. And as Gay said, the data from these surveys go straight into using for our stock assessment reports, for our management purposes. These POWER surveys are approximately 2 months in duration, and the ship time and the crew are provided by the government of Japan. And so it's been a really remarkable opportunity to participate in these large-scale, internationally collaborative marine mammal surveys for really a pretty minimal cost for us. So these two plots show all of the survey areas of the POWER surveys to date, beginning in 2010 all the way through 2025. And so as you can see, it's really been a pretty monumental effort to survey such a massive portion of the North Pacific and the Bering Sea. For the purposes of this talk, obviously, I'm just going to be focusing on those surveys that were in the Bering and Southern Chukchi Seas. So just briefly going over the methods, as mentioned, it is a visual line transect survey for marine mammals. And while large whales are the focus, we do identify and count all species that we encounter. And so the observers will use handheld binoculars, and they scan from directly ahead of the vessel out to the beam, 90 degrees. And the primary observing platform is the crow's nest up there at the very top of the mast. But the data are recorded from the flying bridge, which is that second, the lower red circle. And scientists on the flying bridge do also scan for whales, but they only call out sightings that were missed by the crow's nest. And then there's also a secondary platform that is used about half the time, and this is to obtain independent sightings from a separate platform. And those sightings and those data are used to get what we call G0, which is an estimate of the number of sightings that are missed by just using a single platform. So if we encounter a high priority species, we may attempt to get photo ID photographs or biopsy samples, which is a small piece of skin and blubber that we can use to get just a wealth of information about the animal, including the sex, genetics, reproductive status, health, etc. And then beginning in 2017, when POWER first surveyed the Bering Sea, we included passive acoustics, which has been a pretty key component of POWER ever since. And so for the passive acoustics, I use an instrument called a sonobuoy, which is a free-floating instrument that's deployed over the side of the vessel, and it transmits audio signals in real time via VHF radio waves back to a receiver on the vessel. So if a whale starts calling, I'll hear it pretty much as it happens. And then the other great thing is that sonobuoys have directional capabilities. So if we start hearing a right whale or a target species, I can actually localize or triangulate on their position and then direct the ship over to the animal where hopefully we'll find it, we can begin collecting data. And so these instruments have really been just absolutely invaluable in helping us locate the critically endangered North Pacific right whale, which is one of my favorites, as Gay mentioned. Okay, so getting into some of the details about the surveys I'm going to be talking about. This plot here shows track lines that were taken by the POWER surveys during the 4 years that we were in the Bering Sea in southern Chukchi. So in 2017 in green, 2018 in red, and for those 2 years, we were only in the eastern and central Bering. And then beginning in 2024, we included the southern Chukchi. You can see that in purple. And then again in 2025 in blue. And so we have kind of these two cycles of doing eastern and central Bering, and then again, eastern and central Bering with the addition of southern Chukchi. And this color scheme, in terms of colors for each year of data, that'll be kind of consistent throughout the talk. Now, in 2025, we didn't have any track lines like we did in the previous years. And that's because our primary focus in the southern Chukchi this year was to photograph and collect biopsy samples from as many gray whales as possible. So we kind of focused our efforts just in that blue box looking for gray whales. So going through the results, I first am going to show you kind of all 4 years combined as a way to see big picture trends in marine mammal distribution. And then I'll highlight some of the gray whale specific results, and then finish up with a comparison between those two cycles and why we were seeing some different results. All right, so you're going to see a whole bunch of maps that kind of look like these. So I want to take a little bit of time to explain these. So on the left-hand map, you're looking at the visual sighting results. The track lines are the same as what you just saw, color-coded for year, and the circles represent the individual sightings. And again, those are also color-coded for each year. Then on the right, we have the acoustic results. So those small gray dots are where I deployed a sonobuoy, and then the colored triangles are detections of that species with that same color coding by year. Okay, so for these two plots right here, we're looking at fin whales, and you can see they were pretty ubiquitous throughout the entire southern Bering Sea shelf, you know, even into the deep basin, as well as pretty consistently in the southern Chukchi as well. And there was really good agreement between the visual results and the passive acoustic results. The acoustics follow that same trend. But I do want to point out, though, that fin whale calls are really very loud and can be heard from pretty far away. And so it is possible that multiple sonobuoys are picking up just the same individual. So that could be one reason as to why it looks like there were so many more animals detected acoustically than there were visually. And so here we have results for humpback whales, and they seem to kind of be clustered into three different groups. Southeastern Bering Sea, the deep Aleutian Basin, and then again up in the southern Chukchi. And again, good agreement between visual sightings and acoustic data. For gray whales, grays were pretty much only sighted in the northern Bering and the southern Chukchi seas. A couple of animals to the south of St. Lawrence, clustered, as you might expect, in the Hope Basin and that Chirikov Basin. And with gray whales, there were quite a few more visual sightings than there were acoustic detections. Gray whales tend to be pretty quiet when they're up there on their feeding grounds, and so they're more often sighted than they are heard. Okay, so North Pacific right whale, they are primarily seen and heard in the southeastern Bering Sea near their critical habitat, which is kind of that small, thin black polygon that you can see. It's not super obvious there. But this is a species where you tend to get more acoustic detections than you do visual sightings. There are so few animals, they're so rare and difficult to find. So they tend to be better candidates for passive acoustic monitoring than they do visual sightings. So on this slide, we actually have two species. On the left-hand side are the minke whales. We kind of had scattered sightings throughout the survey area, but these results are visual only. There was not a single minke whale call detected in any years. They tend to be extremely quiet up here on their feeding grounds. We rarely detect minke whales, so they are definitely a better visual survey candidate for sure. And then on the right-hand side, we've got bowhead whales. I've combined the visual and acoustic detections into one map because we had exactly one sighting of two animals only in 1 year in 2024. And there was only one sonobuoy that detected bowheads right near the sighting location. But this was a bit of a surprising sighting for us. It occurred on August 17th, right at the start of the 2024 survey. So I thought it was a little bit early to be seeing bowheads down near Point Hope. So that was a pretty neat sighting for sure. All right, so for killer whales, there was a fairly noticeable difference between the visual and the acoustic results. Visual sightings were mainly clustered kind of in the southern, southeastern Bering Sea, kind of along the shelf break. And while the same is true for acoustic detections, there were quite a few more acoustic detections, including further out into the basin as well. Overall, more detections than sightings. Killer whales are just highly vocal animals, so they are very good passive acoustic candidates. Another species where visual and acoustic results were quite different are sperm whales. So they were only detected and sighted out in the deep waters, shelf break, and farther out into the basin. But you can see there were quite a few more acoustic detections than there were visual sightings. This is very much just a result of sperm whale acoustic behavior. They are long, deep divers where they are clicking almost constantly and echolocating. So they're very much so better passive acoustic candidates than visual. All right, so let's get into some of our gray whale results. So first of all, why were grays such a high priority? So right now there are two populations of gray whales, the eastern and western North Pacific gray whales. And then you have this group of whales that tend to just kind of migrate across the whole Pacific and go wherever they want. And then within the eastern North Pacific gray whales, there are two different feeding groups. You have what are called the Pacific Coast Feeding Group that are kind of seen repeatedly feeding in the waters off Pacific Northwest. A lot of them out here in the Sound, if you can see that kind of green polygon that just popped up right there. But the rest of the Eastern North Pacific feeding animals all feed up in the Bering and Chukchi seas. But not a whole lot is known about the stock structure of these animals up there. So we really wanted to photograph and collect biopsy samples from as many animals as we could, because from those data, we can then get a better understanding of stock structure, body condition, health of the animals, genetics, feeding, etc.
Jessica, not to put you on the spot, this is Gay.
Yeah.
For the audience here, can you just briefly describe what a stock means?
Yes, that's a
That would be
great
super
question.
helpful. Thank you.
Yeah. So when we think of stock, we think of within a species, there are different groups or different populations. And we use the word stock because that is a term that NOAA uses. That means it is an officially designated and a population that is managed separately from another one. So within gray whales, we have these two stocks. We have the Eastern North Pacific population or stock, and the Western North Pacific population or stock. And those are recognized as being two distinct populations. And so they are managed separately. But within that population or stock, you may have smaller subgroups moving around. Those are not managed differently from one another because they're all part of the same stock. So that's what we're kind of trying to figure out up in that Bering and Chukchi is within this one same Eastern North Pacific stock or population, the two are used kind of interchangeably. Is there some kind of structure within there between, maybe some subgroups going on? Also, are any of the Western animals coming over and feeding into the Bering Sea? Is there any overlap? So that's what we've been trying to kind of better understand within that region. So since 2017, we have been able to collect 53 biopsy samples from gray whales, and those are all indicated by the blue circles on the figure to the left. And we've also photo identified 162 individuals. And most of these were collected in the Hope Basin or the Chirikov Basin, as you might expect. But we do also have a few samples from outside of that region as well, including an animal that was biopsied a couple animals biopsied off Kodiak Island from the 2019 Power Survey as well. So a really nice collection. And some of our colleagues at the Southwest Fisheries Science Center are currently in the process of analyzing all of those biopsy samples and those photo ID photographs to try and answer that question of stock structure. Are there any subgroups within that feeding group? And to see kind of what's going on up there. So these samples are really contributing greatly to our better understanding of gray whales. So hopefully once those analyses are done, we'll have maybe a little bit better idea of what's going on up there. But one thing that we did note this year was that many of the gray whales that we saw had heavier cyanide loads. They had some more skin lesions than we typically see. And while they weren't emaciated, they were on the thinner side. They were a little bit thinner than we normally like them to be. And that was a little more pronounced this year than we typically see. So why is that important, right? So gray whales for a while were going through what's called a UME, or an unusual mortality event. And those are kind of designated by those blue vertical shading sections here. And basically that means we had a lot of gray whales dying. We weren't really sure what was going on, but it continued for several years. You could see in the top here, this is the population count, that the population dropped pretty precipitously. The UME was declared over in 2023, but we are again seeing a population decline within this population of whales. And they also are currently having very low calf production rates. 2025 was the lowest on record. And so it's really important for us to try and figure out what's going on, what can we do, how can we help these guys stabilize, recover. So all of the data that we collected in this power survey are going towards assessments that are ongoing to try and figure out overall population health for these gray whales. All right, so now let's get into some of the differences between those two survey cycles and comparing data from the same area, but different years. Okay, so same type of map here that we're looking at, but now I have 2017 and 18 on the left-hand side and 24 and 25 on the right side. I kept the track lines for all 4 years on both sets of plots just for comparison. But again, that same color coding for each year is consistent throughout. And I should mention, on occasion, if we finished the survey a little bit early, we would often go over to the right whale habitat. Again, here's that polygon. And spend our last few days looking for right whales. And so that explains why sometimes you would see sightings outside of the survey area for that year, right? Like 2018 sightings outside the central Bering. And so for these results, I'm only presenting the visual sightings data because the acoustic data showed very similar patterns overall. And now the numbers underneath the years here represent the number of sightings of that species and then the number of individuals in the parentheses. And so this is, this is strictly for the line transect data. I'm not including any animals that were sighted after the survey ended when we would go over to the critical habitat, for example. And just as a reminder, in 2017 and 2018, we did not go into the Chukchi. So for this part of the talk, I'm not really going to be going into details about the Chukchi portion, just because we've only have those 2 years. And so looking here for fin whales, you can see kind of the main difference between the two survey cycles is, first of all, the noticeable decrease in the number of sightings in 24 and 25 compared to 2017 and 18, primarily in the southeastern Bering Sea, but also in the deep basin, almost along this entire blue track line that you're seeing kind of outlined in that left-hand black circle. We traveled almost 300 miles up this track line right through the center of the critical habitat. Only had, I think, one sighting the whole time, and then very, very few on this deep basin track line. And then a similar pattern is seen for humpback whales as well. Overall, considerably fewer sightings in 24 and 25 compared to 27 and 2018. Again, especially in southeastern Bering Sea and along that Aleutian Basin track line. For North Pacific right whales, we did have quite a few sightings in 2017 and 3 in 2018, almost all of them in the southeastern Bering. But sadly, we had 0 right whales at all in both 24 and 2025, even though we specifically went to their critical habitat afterwards to go and look for them. And so here I am showing the acoustic data. I think this lack of right whales is even more obvious when you look at the acoustic data. So now here, same exact type of plots, right? Same division of years, but now the triangles show where right whales were acoustically detected. And then those numbers that you see below the years were how many buoys detected right whales versus, in the parentheses, the total number of sonobuoys deployed. And so you can see overall there were far fewer acoustic detections in 24 and 25. And I think we had only one animal calling in each year that we were just never able to locate. And sperm whales, back to our visual data here, they were only sighted in the deeper water, as we would expect for sperm whales. But again, far, far fewer sightings in 2024 and 25. And again, I think the acoustics data really just highlight this contrast even more. And so you can see in 2018, we had almost every sonobuoy in deep water had sperm whale clicks. It's just littered with red triangles. But now when you compare that with 2025, and I apologize, I know that the blue triangles are hard to see on the blue bathymetry, but I wanted to have the bathymetry in here just to highlight kind of where we were seeing them. There were really very few detections. Most of them were around bathymetric features like Bowers Ridge, which is kind of the circular, chain happening here. The Shelf Break, the Aleutian Islands. And then here, I think this really just kind of wraps it all up into the differences that we were seeing. So here I have all 4 species on one map. So for fin and humpback whales, it's the visual sighting data. For right whale and sperm whales, it's the acoustic data. And so when you look at all of these data combined, there really seem to be just those 2 main differences with the southeastern Bering Sea and then that deep basin track line. Okay, so let's take a look at what was going on and why we think we were seeing so many differences. But before I get into that, I do have to mention a few caveats to these results, to what I'm about to present. So first, these track lines are a really very coarse resolution, right? As you can see, there are gaps between our survey areas. There are areas we couldn't get to. These surveys also, they're really just kind of a snapshot because we're only there for a total of about 2 months. So things could change very quickly. They could have been different before or after we were there. And then finally, you have kind of the usual caveats that come with a visual and acoustic survey, right? So we can only see about 5 miles from the vessel with the handheld binoculars. And although we can hear whales a little bit farther than that with the sonobuoys, a lack of calling does not necessarily mean a lack of whales. And that's always important to remember when we're talking about acoustic results. Okay, so let's get into it. We'll start with the southeastern Bering Sea and comparing 2017 versus 2024. And so again, if you saw last year's talk, I went into a little bit more detail about what's called the cold pool. So for here, I'm just going to kind of mention it briefly and explain it briefly. I've put together this kind of sketch to help explain. So the Bering Sea ecosystem dynamics, they all revolve around sea ice, as I'm sure you all know, and more specifically on what is called the cold pool. So in very strong, heavy ice years, you end up with a pool of extremely cold water that sits on the bottom that will persist well into summer. And this really cold water favors really large lipid-rich copepods and zooplankton that then tend to be concentrated within that cold pool area. But if it's a low sea ice year, there's either a very weak or no cold pool. So this means there are warmer bottom temperatures, and that will result in fewer and smaller copepods and krill in the fall. And they aren't there in concentrations that are large enough to support a lot of whales, right? They're going to go where the food is more dense, more concentrated. It's fattier, right? They're the avocados of the ocean. Now, obviously, it's a lot more nuanced than what I'm showing here, but that's kind of the general idea. A strong cold pool means good concentrations of nice, fatty, rich prey in the fall, whereas a weak or cold pool means kind of limited prey in the fall for that southeastern Bering. Okay, so let's see then what was going on. So this plot here shows the bottom temperatures for 2017. And that red polygon you see again, that's the right whale critical habitat, just to help with orienting and for reference. And so in 2017, we actually had a pretty decent cold pool that would extend all the way down into that critical habitat. And those are those darker blue areas. That cold pool tends to stay kind of nicely contained within the 50 and 100 meter isobaths, right all the way down into the habitat in the southeastern Bering. But when you look then at 2024 bottom temperatures, you can see that the cold pool stopped much farther north and was pretty much non-existent just south of the Pribilofs. There was almost a 3-degree difference in bottom temperatures within the habitat between those 2 years. So what does that mean for their prey? So these data were collected in the summer or fall months, so roughly the same time as our marine mammal survey. And the 2017 zooplankton data were collected right along the 70-meter isobath. So that runs right down the middle of that cold pool. And so on the top, we've got concentrations of large copepods, and on the bottom are euphausiids and krill. And so right whales tend to target copepods, fin and humpback whales tend to target euphausiids or krill, small forage fish. So by looking at how much prey is there, that kind of gives you an idea as to whether it would be a good prey year for those species. And so now, looking at 2024, these are the data from the 2024 survey. And the first thing that I want to point out is the wildly different scales for the large copepods. You're looking at a difference of a factor of 10. But even large, different scales aside, there was essentially 0 large copepods or euphausiids in the southeastern Bering Sea in the summer and fall of 2024. And so then let's compile it all together and kind of see the whole picture together. And I have to note, these data are preliminary. I have just been overlaying plots on each other. I haven't done any formal analyses. That is hopefully going to come now that we've finished the whole circuit. But for now, these are a little bit ad hoc, so apologies. So again, here's that bottom temperature plot showing that cold pool in 2017. And so when you overlay the zooplankton data on top of that, you can see how that cold pool comes all the way down, and we do have decent numbers of large copepods all the way down into the southeastern Bering. Okay. And then overlaying the sightings data on top of that, we have quite a few sightings in 2017. They go all the way into Bristol Bay. So really a lot of good, rich prey for these guys. And now doing the same thing for 24, and I've shaded 2024 to kind of indicate that it was a warmer year. So we've got our bottom temperatures showing that the cold pool essentially stopped by about 58 degrees. Now we superimpose the zooplankton data, at least for the copepods, and you can clearly see the lack of prey occurring in the whole southeastern Bering. Adding our sightings to it, almost all of our sightings were farther west, closer to the shelf break or in the Bering Canyon. So this lack of cold pool and the lack of zooplankton in the southeastern Bering is very likely that reason why we had such fewer sightings in 2024. All right, so now let's move on to the Deep Basin. I know this is a little bit far from your primary region of interest, but I do think it's really interesting, and I hope you do too. So getting into some of the ecosystem dynamics out here. So this map shows the currents that flow into the Bering Sea up from the North Pacific and from the Gulf of Alaska. They kind of come up through all those passes, turn the corners, they'll follow along the Aleutian Islands chain, kind of come up the shelf break, swoop on over into the shelf before heading north. And so looking at this, I also want to show, this is a map of what's called transport, and that is basically how many nutrients are being moved through the water up through those passes and into what specific areas. And so everywhere where you see kind of those brighter oranges, yellows, and reds, that's where there are a lot of nutrients being mixed up. And when you combine that with the currents, what happens is it creates little eddies all around that tend to concentrate all those nutrients and create these little pockets of productivity. And so you can see a lot of them tend to occur along the Aleutian Island chain, up the shelf break, down along the Russian coast, and especially here in this Bering Canyon region. Okay. So how does this translate then into what we are seeing? Okay, so here's our 2018 sightings in red. And if we, again, very ad hoc, overlay the transport over our map of track lines and sightings, and then again, with those eddies, I know it's getting a little fuzzy, but I think it really does kind of paint a pretty nice picture that our sightings tend to align pretty well with those eddies and those areas of high transport and high productivity. There's a lot of sightings along the Aleutian Islands, along the shelf break. And now looking at our 2025 sightings, right? Those are the ones in blue. And again, if we overlay first our transport map and now our eddies, you can see we do tend to have a similar pattern of sightings, right? Near the eddies, along the shelf break, the Aleutians. But that one, oops, wrong direction. That one basin track line isn't kind of really positioned near any of those eddies. It's a little bit out there in no man's land. So we're wondering perhaps this is why we really didn't see anything on that transect, right? That said, our 2018 track lines, even some of those were a little bit out in no man's land as well. And we still had some sperm whales. We had some sightings out there. So right now, my best guess is that there's a lot of interannual variability with the transport and the eddies, the amount of nutrients coming in, how strong those eddies are formed. So right now, my guess is that 2018 was a strong year with strong currents and strong eddies, and that the productivity kind of extended beyond the boundaries of those eddies a little bit. But that in 2015, it was a weaker year. And so those animals were distributed more closely to those eddies rather than further out into the basin. That said, there are very few studies or surveys, especially marine mammal surveys, that occur out in the deep basin. It is so logistically difficult to get all the way out there. I even struggled to find plots of any kind of recent data out in that region. And if I'm being perfectly honest, I'm not entirely sure which year for that area was the normal year and which was the anomalous one, if there even was one. Everything I just presented is a hypothesis that we are going to start looking into, hopefully have a better picture. But if anyone here is an expert in Aleutian Basin ecosystem dynamics and has any other ideas or hypotheses, I am very much all ears. I would love to chat. All right, so just kind of starting to wrap things up, I want to chat about the future of power surveys in the Bering, which currently it's unknown. We don't know. At least for the next few years, the plan is to be in waters south of the Aleutian Islands. So if we do end up getting back into the Bering Sea, it likely won't be for several years. I'm hoping we do. This is an area that, as you know, is constantly changing. It's undergoing rapid change. And I'm also really excited about surveys that are occurring this year in the Bering, because this is a pretty heavy sea ice year for the Bering Shelf. So this plot shows the sea ice concentration as of yesterday, and the sea ice extent maximum is one of the largest that we've had in a very long time. And so it's setting up to be a very, very strong cold pool year. So it'll be really interesting to see results from the surveys that are occurring in this region, and add just a few more pieces to the puzzle of what's happening up there, how are things changing. I do briefly want to mention where you can go to actually request the use of any of the IWC power data. So you can go to the IWC website and the portal. If you click on the database portal, it'll take you to the database, to the data request page. And you can also look at all of the cruise reports. They're all available online. The 2025 one was just recently finalized and will be uploaded imminently. I'm happy to help out. If anyone would like to go through this process, please reach out. Finally, here are the data sources and the references that I mentioned in the chat. I absolutely have to thank Phyllis Stabenow, our oceanographer extraordinaire, and Dave Kimmel, our resident zooplankton guru, who helped me try and make sense of a lot of these things. And with that, I am very happy to take any questions. Thank you guys so much.
All right. Thank you, Jessica. That was awesome. And whoever does your graphics, if that's you, I mean, fabulous. That was like
Thanks. That was me.
beautiful. So look, you've already got people clapping. So we know we're so grateful that people are talking to us, especially after a long day at work. And this is the time to throw some love at Jessica Crance, either in the chat, but you're getting a lot of these electronic, I don't even know how to do those claps and things like that. Thumbs up. You're getting thumbs up all around. And so well done. And we'll start off. We've got comments and questions in the chat. And I think we'll start off. Doug, I see you, but wait one sec because we have someone who showed up to the office. And if you show up at the office, you get to be head of the line. Honestly, go for it.
How can you tell the different whales from their sounds?
That is a great question. So the easiest way is that if we happen to be out and we see them and we can deploy a hydrophone, we can visually see the animal and collect recordings at the same time. So we know, hey, we have a gray whale here. These are the sounds we're hearing. That's a gray whale. So most of what we know about the sounds these animals make come from surveys where we happen to have that concurrent visual and acoustic data happening.
Good.
Very interesting.
Great, thank you.
All right. That's in-house comment. With that, okay, thanks, Ethan. And go for it, Doug.
Yeah,
the floor is yours.
Fantastic presentation. Really enjoyed that. It was great.
Thank you.
A question about the visual surveys that you do. To what degree might they be influenced by poor weather where you have bad visibility or when the observers might be a little off their game?
That's another great question. So yeah, poor visibility means you can't see the whales. So we do have conditions where we will stop surveying. We have to have a minimum of 3 miles of visibility. And if it's raining, we stop. And if it gets too windy, right, because winds pick up the seas and you get all the white caps and the spray that will hide whales. So if the winds are greater than 20 knots, or if our visibility is less than 3 miles, or if it's raining, we do not survey. Yeah.
Thanks.
Yep.
All right. Thank you. Sue, I see your hand is up. The floor is yours.
Well, thank you. And thank you, Jess, for really a great presentation. As you probably have guessed, I'm gray whale focused these days. And just wondering about the body condition that you noticed, the poor body condition this year. I'm sorry to know that you're not going to be going back anytime soon up to the Chukchi. And I guess 2 things, really. The first is easy. Will you be reporting these results to the scientific committee next month? Because the Marine Mammal Commission is hoping to bring information in from that meeting to a workshop we have planned in September. And then secondly, in terms of identifying gray whales, I know that in development is gray whale ID through Happy Whale. So I'm wondering if the photos you have go there.
Great questions. Excuse me. So for the first one, Amy Lang is putting together a document for the upcoming IWC meeting. She is not focusing so much on the body conditions because these are at this stage, it's just kind of all anecdotal. There haven't been any kind of formal analyses in comparisons, number of animals. It was just a general, hey, this is what we were seeing, nothing formal. So she is presenting a paper about all the biopsy samples and the results from POWER, but not really going into body condition. And then, oh, I'm blanking. Help me out. Question number 2.
Happy whale.
Happy whale. Thank you.
Happy
Thank
whale.
you.
What is
Appreciate
Happy
that.
Whale? What is
So-
Happy Whale?
Happy Whale is a website where anyone can upload photos of whales that they have seen, and there is an algorithm that runs where it will attempt to match that individual with previous sightings of the animal. So it's been really great. For example, for humpback whales, you can upload a photo of the humpback flukes, and it will match it to any other previous sightings of that animal. And so I do know that they upload a lot of their photos to Happy Whale. I don't know if these have been yet, and I don't know if all of these are going to be uploaded or not.
Yeah.
We got a little trigger happy with taking photos, and so the photo database at the IWC is quite large, and it takes a while to kind of curate those and find good examples. We certainly are not going to be sending 6,000 images to Happy Whale, so I believe it is the plan to do so, but they are not yet uploaded.
Okay, thanks, Jess. Great presentation.
Thanks, Sue. Appreciate that.
All right, now let me see. If we have any questions I may have missed in the chat. Diomede, we've so many whale sightings here on Diomede, yet you couldn't see until we, Diomede, set up single beam echo sounder on a mooring. I'm curious, when was that, Diomede?
When was it?
Yeah.
Never happened, but you know what? I think it needs to happen because
I see.
we see whales all the time, here on Diomede. But we're not included to share our information. Whoever's looking for whale sightings out there, like is it the Whaling Commission?
Mm-hmm.
Or was it more? I missed it. But
OPIC, it's me. OPIC, we were
Hi,
out at
Sue.
sea together. Hey, OPIC. Yes, I'm always interested in whale sightings. So yeah, I'd like to hear more about your ideas, for detecting and reporting in what you're seeing there, because you are the gateway.
I know, and yet we are not on these tracks.
Well, it's
For your
because,
sightings.
OPIC, ship time, and Jess is doing a great job out there with the power crews and what they can do. But I understand what you're saying too. Whenever we're flying transects or on ships, ocean is big, right? We're missing a lot of it. So we just we're limited in that way. But getting information from the Diomedes and from the gateway there, we need to figure out a better way to do that. That's the bottom line.
The better way to do that is contact our tribe. Don't go through a consortia to gain our help.
Yep.
Because I'm pretty sure Diomede would want to be involved.
Very good. Very good. And I remember your invitation there. We had a fine time.
Yep. I think there should be a mooring, acoustic eco sounder mooring should be deployed somewhere south of our island and probably north. Maybe another one on the east side would be nice.
So OPIC, thank you for that. I think probably there may be. It's just we don't have access. I would imagine the military probably have Diomede pretty well figured out. I was thinking if you put a echo sounder or whatever it was, some kind of
echo sounder.
There's one north of the Diomedes. It's probably further north than you would like, but it's been there a long time as part of monitoring the Bering Strait, advection and other things we're interested in. There has been an acoustic mooring, Kate Stafford, through University of Washington. So
we'd love them to give a talk to the region.
Yeah. Let's pull Kate Stafford.
Well, I'm just saying there
Yeah.
is an acoustic mooring north of Bering
Awesome.
Strait that's been occupied for quite a while.
Great. Do you know
cool,
who's
cool.
in charge of that? You said Kate Stafford?
Kate,
Okay.
Kate
All right.
Stafford.
We'll continue that. And thank you, Opic, and thank you, Sue. That's awesome. Good discussion there.
Are you
And when you're
rushing us
talking
away?
about an echo sounder on a beam, I thought, man, I bet the Navy's got something, and I'm sure the Russians probably have something. They're just not making that data public
I
on
don't think
what's
it's
passing
that
through.
gay. I don't think
Yeah,
it's that very much. It's not so rocket science. It's just a little equipment that you can
yeah,
deploy with a
yeah.
mooring and set down for several months.
Yep. I
I'm
think it's a
just
good
wondering
idea.
what they cost because I know our tribe can get one.
There you go.
Mm-hmm.
All right. Good point, Opic.
Yep.
And we've got Gail Ashton, who's been very patient. Go ahead, Gail. Your floor is yours.
Hey, just it kind of follows on a similar line, but and a little bit south of Bering Strait, but there's an increasing number of tourism vessels operating, especially along the Aleutian Islands, full of citizens with large cameras looking out for whales. We're generally aware of happy whale, but if there are other places where citizens can submit those images in a way to capture that information, it's worth reaching out to the vessels, the operators, because they are interested, they're trying to contribute to citizen science, and it could be a good source of data and for others on this call as well.
Yes, absolutely. Thanks for mentioning that. Yeah, happy whale's one of the obviously the most well known. If it's anything like a carcass that is seen, that those are really helpful for us to be reported. Sightings of right whales, for example, if anyone is out there and happens to see a North Pacific right whale, you can email me. My email's right there at the top. But yes, the whale watch operations are absolutely a really, really incredible source for us for a lot of reasons. Yeah.
All right. Jessica, I'm just dropping your info here so people can get that. And also, I don't know, there's some NOAA people on here. If you could drop in the chat that IWC portal, so because it's tough when it's on a slide, but but it's good you put it on a slide. No bad there. But if it's in the chat, if someone can dump that IWC portal thing, then people can snag that and look up if they want to have those cruise reports for some of the other stuff.
All right.
Oh,
I just
you're on
dropped the database portal. And then if you just type iwc.int, it'll take you right to their website, iwc.int/power. Will take you to the power survey specific website.
Awesome. That's wonderful.
Yeah. Also email me. I'm happy to share all of the sites as well and help out.
Yeah. If we get a right whale sighting, I do know who to call. That happens up here. We have right whale in the Bering Strait region, and that's not, it's unusual, but not that unusual. So
yeah.
All right, Doug, you've got the floor.
Another one here. But
Yeah,
I just read something in I forget it was either Alaska Beacon or the Anchorage Daily News, and they had mentioned about the article was about harmful algae in the Bering Sea. And they mentioned about two finback whales, and they suggested that those finback whales may have died. This was several years ago, I think. But I think they were attributing that to the harmful algal blooms. So could you comment on that and to what degree that might be an issue?
Yeah, absolutely. So for those who are unaware, we call harmful algal blooms. So whenever you get a large bloom of algae, there are certain algae like dinoflagellates that will produce biotoxins. And when those biotoxins are ingested in large enough numbers, that can cause a lot of really serious health issues, neurological issues. And so harmful algal blooms, they're thought to be increasing worldwide. It's an area that we're really, really focused on. And there have been some studies that are showing that harmful algal blooms are increasing in the Arctic, and particularly for, I think it was bowheads and walrus are already starting to show some evidence of these biotoxins. And to my knowledge, there haven't been, I don't know that I don't remember that those fin whales were definitively that the cause of death was definitively harmful algal blooms, or if they just happened to also have those biotoxins in their tissues. I don't know if it was just, kind of correlative, or if that was in fact determined to be cause of death. But it is something that is of increasing concern because we are seeing more harmful algal blooms occurring. And the higher up on the trophic level you go, the more of those toxins you ingest. Yeah.
I don't know that they took tissue samples, but I remember the article did talk about at that same time there were walruses and fur seals and a bunch of other marine life that had showed up at the same time. And so I think it's more anecdotal that it was going to be harmful algae. But
Yeah.
more recently, there were a bunch of fur seals that had died too on St. George and St. Paul. And they
Yep.
were sampled for tissues, and it was positively identified that they were
Yep.
harmful algae.
Yeah, absolutely. Yeah, fur seals are a little higher up on the trophic food chain, so they tend to get higher levels of those toxins. And it is something that again, people are measuring, and we are seeing values being reported in samples that are being taken. I think right now the question is, were those levels for some animals, are those levels high enough to be cause of death, or are they just kind of correlative?
Okay, thank you very much.
Yeah, thank you.
Thanks, Doug. And I'm putting in the chat that sort of the big NOAA story on that from back in February. And they use the word linked. So that's the kind of a key word to what Jessica was referring to, if they're
Yeah,
the
definitely.
linked, is my understanding. So there's a little bit of you have to read the paper.
Yeah.
And all right, I've got a question. If no one else has one right here.
Yeah, fire away.
Now this comes up. We just had a straight science on spectacled eiders, and so the person who did show up but they didn't never asked it from the audience, but I get a lot of questions later and things. And when you're seeing, so for spectacled eiders, we have an area of Norton Sound, which is to the east of Nome, and that is critical habitat for spectacled eiders, and so you can't do certain activities there. But they haven't really checked it in a while, and there's certain restrictions on fishing, and especially I think herring is over there, and so there's always some conflict a little bit, or we'd like to get in there, that kind of thing. And who's got the latest news on the eiders? For stuff like the gray whale, I mean, it was pretty dramatic that the gray whale, you couldn't find them. Is that the timing of the cruises is kind of set? Is it a thing, like when you went through that 300-mile transect right through the middle of the sweet spot there, and you got very little for that? Do you think that is there an indication that the timing has changed such that if you go to an area you where you think you would have regular, are we at that point where the timing is off for, they've already given up and they've adapted, they've headed out in a different direction or gone further north sooner or later, or somewhere that it could be a possibility that it might influence your results?
I think, there's kind of two components to it, right? It's the timing of the survey, when we can get up there, and it's also, of course, what's happening from an oceanographic standpoint. But we are up there kind of late enough where if the oceanographic conditions weren't favoring large whales in that area, they would already have moved on to a different area. So yeah, it's entirely possible that our surveys are just kind of too late to get that initial influx into the southeastern Bering before they move on to where the getting is better. But I think it's also just, it's so strongly driven by the ecosystem dynamics of that year, the sea ice, the cold pool, whether we had an earlier or later spring bloom. Yeah.
Do you think, my other question is, when I looked at, you did a really great graphics there with the eddies and the shelf and the high productivity, and the whales are in that southern Bering Sea.
Yeah.
That's also an area of large commercial fishing, both on both sides.
Yes.
And I know those whales are not, you were right, we're way south of us, but is there any, you're looking for whale photos, whale sightings, the fishing community would they be, I don't know if that's something that would be counterintuitive. They don't want to tell you they're seeing whales, but maybe at the same time, if there's some benefit to showing you where the whales are, you might have a great partner in the fleet. And the other
Yeah.
opposite side of that is there any concerns for seeing these large whales and the commercial fishing fleet, which probably right at the shelf break is trawling midwater, maybe pollock or something else?
Yeah, great questions. So it is kind of a tricky conversation to have because the fishermen obviously don't really want to give up their prime fishing spots, but we do have observers on board that will kind of give us sighting reports for anything that's unusual, but also to get to your second question with the overlap, it is a very there is a lot of overlap between the large whale distribution and these fishing activities. The problem is we're having a hard time quantifying the impacts of these fishing activities in the Bering on these populations. For example, right whales, only 2 animals in our catalog have entanglement scars. But is that because they're not getting entangled, or is it because it's so remote that they're just not getting reported? A lot of the bowhead whales that come down into the Bering over winter, a lot of those guys have evidence of entanglement scars on their bodies and over on their peduncles or that area just
11%.
north of their,
to 11 to 12%. And that's where,
Mhm.
yeah, we don't have a big giant crab
Yeah.
fishery in U.S. waters.
Right.
Well,
But then, entanglements are increasing all along the West Coast for humpback whales, for gray whales, for fin whales. So it definitely is an area of concern. It's just been difficult to quantify the actual impacts to the populations.
Right.
Yeah. And I'm sorry, my camera seems to just have decided to stop working at some point. You just have a lovely image of the Golden Gate Bridge. So I don't know when that happened, but apologies.
Yeah, you kind of, it's like you're ghosting your thing there, but that's
it's
okay.
not
That's
turned
actually,
off.
I've never seen that before.
It just apparently decided it's done. It's done looking at me, I guess.
No, it's all right. Well, any other questions for Jessica? We really had a good presentation, and thank you for dealing with all those questions.
Yeah, happy to. Thanks everyone for chiming in. That was a great Q&A session.
Yeah. So I will, Jessica, if you want to stay on, and I don't know, there's some folks from your office, they're welcome to stay on too, if you want to stay on for a sec. For next week, we're going to go on land next week for Strait Science. We have the Oak Ridge National Lab in Tennessee, which is one of the big federal labs in the country. They've been working out here for, at least a dozen years on their NGEE project, looking at how the tundra plays a role in how carbon moves in the land and the air and what our future holds. And they've been working with the Native Village of Council, with the Council Native Corporation on some land that they've got over on the Council Road, and they've been doing it for years. And this is part of a larger National Science Foundation project that's connected all the way up to Utqiagvik. So it'll be Bailey Murphy. She is a researcher with Oak Ridge National Lab, and she's going to give us some of their thoughts about their land model and some of the work they've been doing on the Council Road alongside with the Council Native Corp. So stay tuned for that. That'll be very local and on land. So we will see you Thursday, April 2nd. Same bat time, 6:30, and you'll see the notices for that go out here probably tomorrow. With that, we thank you all so much for coming. We'll see you later and have a good night, everybody.